Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. The Predictive Analysis Library, or PAL, allows developers to embed data mining predictive scenarios into their own applications. In this video, we're going to look at the key concepts associated with using the Predictive Analysis Library. Effectively, what you need to do as a developer to make use of this powerful capability. As we mentioned in the Getting Started video, and it's always worth reviewing that video if you've not already seen it, we need to be very familiar with the Predictive Analysis Library documentation, in fact the reference guide, and that's available from help.sap.com HANA_appliance. In fact, we have a link from the last video here. We can open that document directly. So when we look inside the documentation here and the reference guide, we will see that there is plenty of information on how we get started, but also there is a reference for each one of the different predictive analysis library functions, whether that's clustering, classification, association, time series, etc. However, when you call these different functions, there are a number of concepts that are common, the same kind of approach that you take all the time. And that's what we're going to cover in this video. So again, we won't need to repeat that in every single video going forward. So the way we work with the Predictive Analysis Library is through HANA Studio, of course. Now, one thing to be have in your mind and be aware of at all times, the Predictive Analysis Library and the AFL in HANA SPS 5 and beyond is very much table-based. That means that the way you interact with the Predictive Analysis Library is pretty much through tables, whether those are input tables or output tables with results, or if you want to tell the Predictive Analysis Library what you want it to do, you would do that through parameter tables. And in fact, there are other tables we will need as well. So when we want to work with the Predictive Analysis Library, or the PAL, we need to be working very much with SQL script and creating and managing tables. Now, there are in fact several phases to the process. The first thing we need to do to make use of a Predictive Analysis Library function is to generate a procedure. That's something we do once for a particular application, and once we've generated that procedure, we can then start to use it. Now, in order to use it, we would need to set up the input and output and parameter tables, and we would actually then need to call the procedure and deal with the results. So there's a kind of as an initial setup of creating the procedure, followed by an application setup and runtime where you're actually making use of that procedure. So the way it works with the Predictive Analysis Library from SPS 5 is that the AFL schema is the area where you need to define the procedures. Now, in fact, we don't see it defined here because for the moment it's empty, but what we're going to do is to define some types and the procedure within the AFL, or the _sys_AFL system schema. So what we need to do, we're going to be working with SQL here. So we'll open up a SQL window. The first thing we want to do is to set the schema to sys_AFL. So that we're working now with that system schema. So we've now set that correctly. And for our example, and we'll not go into the details, it's a simple exponential smoothing time series example, is define some types. Now, let me just paste in this code. We're going to create 3 types. Again, I won't go into the details of this specific algorithm. We're just looking at the overall flow here. We're going to create a type that represents the input data. That's the first one here, which it's like a table. It's got the ID and the amount we'll be looking at to do our time series analysis on. So that's our input data. We create a type that represents the structure of the parameter table, and this structure is in fact the same basically for every Predictive Analysis Library algorithm. We'll see more about that in a moment. And then also we create a type for the results table. And what we also then need to do is to create something that's called a signature table. And the signature table is the place where we make the definitions, we refer to these types and we ask the AFL to create a procedure for us. And it's that procedure that we'll then use later when we want to call the algorithm. So we create a table. Again, the signature, it's pretty much always the same structure. You have an ID, a type name, and a direction. Is it input or output in terms of the table? Because it's always table based. We have the type of the data set, the input data, the type of the results, and also the parameters, which is our second input table. Once we've created those types and we've generated this column table, let's just do that. So let's run that code. Okay, now if we go to the sys AFL schema, let's just refresh our catalog. We'll now see the sys underscore AFL schema. If we go to look at the table, we'll see there is a new PAL underscore TS signature table. And it was up to us to choose the name. Other people may use the AFL library here, this schema, so make sure your name is unique. And if we just preview that data, we can see we've created a simple table with 3 rows with the ID, the type name, and the direction values. And that is what the predictive analysis library is expecting from you. Once you've done that, you can then call this wrapper generator procedure. And this is stored within the system schema. So you should always check that procedure exists. If we go to System and Procedures, we can see the AFL wrapper generator procedure exists. When you restart the HANA server, it will no longer be there. So in the Getting Started video, I showed you how you can recreate that procedure whenever needed. So we call that procedure, and again in the documentation it will give you the name of what you're calling it for, in this case AFL Predictive Analysis Library, the name of the algorithm that you want to use, the signature file that you've just created that has the details in it, and most importantly the name of the procedure you want to create. And that procedure will be created within the _sys AFL schema. So we now call that, and that statement has run. And if we go to sysAFL, we now look at procedures, and we scroll down. There's already quite a few in here. We can see we have this PAL underscore TS time series underscore S for single smoothing. That's just my naming convention there. We can see that that procedure now exists. So we've done the very initial setup. The next stage, once you've created that procedure, is you want to set up your environment for working with it. Now you don't need to have your source data and your results and your parameters within the _sys AFL schema. Typically you would want to maybe do that in your application schema. And I've got an application schema here called PAL, where I've got a number of tables that we'll be using through some of these examples. So what I'm now going to do, make some application kind of setup settings. So first thing is we need to set our schema to the PAL schema, so we'll be using that from now. Okay, that's done. And we need to now define the input and output tables that we referred to in that signature table. We need to actually define them physically. So they actually now need to exist. So for example, what we can do in this case, we can use some code that I created earlier. For the input data, you can, of course, we've got an input table here, in fact called order facts, and we've got a number of columns in there. But what very often happens when you work with the PAL is that you create a view, which has no performance overhead when you're working with HANA. Views are non-materialized, but it means you can get the right columns, just the columns you need, in the right order, available very, very easily by doing a view. And if you need to, you can, in this case, it's actually aggregating, summarizing the data across time, across our calendar ID value. So you can do all sorts of manipulation. You don't have to take your source data and put it into another physical table just to be able to use a PAL algorithm. So very often for the input data, it may well be that you're creating a view that conforms to the structure we defined a moment ago when we created in the _sys AFL schema. So we create a view for the input table, or the view in this case. We also need to have a table for the parameters, and as we already created types, then actually one thing you can do here is just use the like and easily create a table and a results table, which is a new table for us here, which actually fits to the type we just created. That's a nice little shortcut, saves you having to write the same code twice. And what I'm also going to do here is create a little view for our results, because we'll see the results that we create are maybe not fully in the format that we want. It just gives us the raw results, but we may want to do something to make that a bit more usable. So in this case, we take the results we get and we're actually joining that together with the input view that we also created. We join those together so that we can actually have the input values and the predicted values side by side, so we can analyze them together. So again, none of this is actually required to be done exactly this way. This is an example of how typically you might want to work with the AFL. So let's create those tables. Let's run that code. Okay, it's all run through. We've created our empty tables and our views. What we also now want to do is to populate the parameters table, because for the moment it's empty. So for each algorithm, you're going to have one or more different parameters that you set. And in the case of the single exponential smoothing, there are typically 3. The raw data column represents which column of the input data has the actual data, starting from 0. So column 1 is the second column that's in that table, which was the sales amount. The alpha we'll talk about in another video. It's a tuning parameter, and the start time, again, it's something specific to exponential smoothing in terms of when you want to actually start the smoothing process to begin based on the input data. So we're going to now populate that table, and if we now go and refresh within our schema, we'll see that we've got some new tables. We've got TS params, TS results. The results is empty, but if we go and look at the parameter table, you can see we've got, and it's pretty much always the standard structure, you've got a name with the parameter name that you get from the documentation, and either we have an integer value or a decimal or double value, or we have a string value. And normally only one of the 3 integer, double or string arguments would be completed. Basically, it just is a very generic table that allows you to put in parameters of 3 different types. So again, the documentation will tell you which parameters you can do and whether they're integer, double or string values that are entered. So we've created our parameters, so now we're good to go. So basically we've set up an environment where we can quite easily now start to perform some analysis. So in terms of your application runtime, how you now want to use this procedure, we can do several different things. Again, we're going to be working, in this case, within the schema. So the schema is a predictive analysis schema that we've got. Optionally, you might want to update some of your parameters, because what we did before, you probably only need to do once, whereas each time you want to call the procedure, you might want to tweak some of the parameters you've got. So we can update that parameter table at will. You may well want to empty the results table, again, if you're going to run this multiple times as part of the application. You don't need to actually delete and recreate the table each time. You can simply clear out the data that's there and be more efficient. Same for the parameter table, you can just update the values you need to. You don't need to create the whole table from scratch. And the final thing is you need to make this call to the procedure we generated right at the beginning. So this is in the _sys_AFL schema, and we called it the PAL_time series _single, so TS_S, and we send it the 3 parameters that are required. So we've got that input view, we've got the parameter table, we've got the results table. So we can now actually run that, and it runs. But we don't see a lot of results just like that. What we need to now do is, for example, go and look at the results table. So if we go to the table we created, this will now be populated with some information. In fact, what we can see, we've got our calendar ID, we've got about 2 years of data. We can see we've got the different sales amounts here, which have been effectively predicted or fitted by the algorithm onto our different sets of data. So what we also might now want to do is look at the results in a little bit more interesting way. So we've got our results view, and in our results view, if we open that, we can see we've now joined together. So for all time periods, we've got our original source data, and we've got now the predicted, the fitted data that's coming from the algorithm. We can see those two together, which means, for example, we could perform some easy analysis. This is what you would typically embed into your application. Maybe we'll look by calendar ID, the sales amount, okay, and then we can see the new predicted amount. And in this case, it's often good to show a combined bar and line. So now we can see in blue, we've got the original sales amounts, and now we can see our fitted values. That fit's not perfect yet, but we'll get more into the science behind this fitting process in a future video focusing on time series. Now, there's one final thing to show you and to talk about in terms of generic usage. This ability to call a procedure that we've set up in the sysAFL, this is not available to any user. I'm currently working as a system user that does have this right. But if you're writing an application where you're having a different user, the user logs in as himself, or you have application-specific users, you would need to make this capability to execute AFL procedures effectively for the predictive analysis library. You'll need to make that possible for the user. So just to show you, if we go to security and look at the roles, you'll see that there is a role defined called AFL underscore underscore sys underscore AFL underscore AFL PAL underscore execute. And it's this role that you need to assign to a user. So if we were, for example, to create a new user, and we will call him, for example, PAL user, whatever you need for your application, what you need to do is come here and grant them the role of this execute. So we can filter on AFL, choose the predictive analysis library, the PAL execute, and make sure that your user has got this right or this role granted to them. Then they will be able to execute these calls like this from the application layer.